welcome to today's episode of Decisions Now. I am your host, Erin Pearson, along with my co-host, Rigby Chavala, who is the CTO at Evalueserve. Today, we are thrilled to have Rob Albritton on as our guest. He is the Senior Director of the AI practice at Octo. Rob, welcome so much to our podcast today.
Thank you. I appreciate it. Happy to be here.
Well, we're happy to have you. So just to jump in and get started, we're going to be talking a lot about some of the really cool and innovative things that Octo is doing with AI today. And you guys have just built your new AI lab. But can you just start with setting some context? What does Octo do?
So, generally speaking, we are a digital modernization company for the federal government. So, exclusively federal government work. So, we're a contractor and we work in a lot of different domains within the federal government. So, we have a BU, business unit focused on healthcare. We have one focused on DoD and intelligence community. So, that's Department of Defense and intelligence community. And then one focused on national security and civilian agencies. Those would be like DHS and U.S. Marshals and folks like that. So a lot of cloud modernization, migrating operations from on-prem legacy systems to the cloud. And then recently, though, we've shifted. I think we're calling it Octo 3.0 or something to that effect. But Octo 3.0 is focused on things like this AI innovation center that we've just built, and I think we're going to talk about. But that is, more emerging technology. So AI, machine learning, data science, blockchain. I could probably throw more buzzwords out there, but all those things we're all interested in.
No, that's pretty exciting, Rob. Earlier when you were showing your premises, I really want to come there and see it. But again, to your point, a 3.0 doesn't just mean a number. It's a lot of effort in the background, I'm sure, and for you guys to switch your vision. So I'm excited to kind of hear from you about what are these cool innovations and AI specifically that you mentioned as well.
Absolutely. Is that so I can speak to that for sure. There has.
Sorry, I didn't clarify my question, right? So especially in defense, right? Like you were talking about for the federal government, especially AI in defense is typically time critical, needs to be real time and so on. So I was kind of going there is how are you helping there, and why is it important? How is it important?
Yeah, you're spot on. We actually just had a conversation with a company in here about 30 minutes ago, believe it or not, and we were talking about they had a requirement for basically their software could only run on a minimum. It had to have a minimum of six GPU servers to run this software, and I had to politely say no, that's just a non-starter. By and large, generally speaking, in the DoD, especially when you are talking about organizations that do more tactical, more work in the tactical realm, where you're disconnected, you're in austere environments where there's no connectivity, no broadband internet connectivity. You're not pushing data back to some data, to some cloud computational resources, right? And having that level of servers out there is unrealistic. So we have to be able to do it on edge compute as much as possible, which is one thing we focus on here at Octo, and especially in this OLabs organization, this OLabs Innovation Center. A lot of our focus is on how do we take AI applications that today require massive cloud computational resources and move it to the edge so that the warfighter can benefit from those applications as well. And then the other thing is, like you said, real time, right? We've also had conversations recently at a conference about doing batch processing on data. The unfortunate reality is batch processing. It's awesome, but you have to collect your data, then process it, then get an output. we do streaming processing, real-time analytics, right? And that is critical when you have combat scenarios where lives are at risk, and you have data being collected in real time. It only makes sense that the analytics should be done on that data in real time or as near real time as possible.
I it's really cool what you guys are doing. There's a lot of use cases which we're going to drill into in just a second, because you guys are doing some quite interesting testing and everything in the labs in order to help people. But how are you guys? How are you putting all of this together to enable it to be real time, given all of these constraints that you have? So, what are some of the new innovations that are coming out that are really enabling you to do all of this?
So I hope it's okay that I jump in a little bit and talk about O
Yeah,
labs.
yeah.
So because we do leverage O labs for exactly that. So O labs is our 15 plus thousand square foot innovation center that we've spent the better part of 2 years building here in Reston, Virginia, and it is focused almost exclusively on tactical AI. Now we don't at Octo, we don't only do tactical AI. We do have other customers: U.S. Patent and Trademark Office, FBI, NIH, National Cancer Institute. We're kind of all over the place, but this lab was almost purpose built for the tactical AI use cases, at least initially. And what that requires is, first and foremost, it takes a lot of computational power to train machine learning models, right? And increasingly so. And so we built our own on-prem data center, and it's a heterogeneous data center. So the infrastructure, when I say heterogeneous, that means we have many different kinds of compute architectures in our data center. So we have NVIDIA platforms, we have vast data platforms, we have Pure Storage, we have Dell, EMC, we have, and the reason we do that is because our customers have many different kinds of infrastructure, and they want to know that what we're building can run on the infrastructure they've already purchased, right? So we can actually demonstrate that here in the lab. So we set the lab up to basically follow an ML pipeline process. So you start at the front and you have a data center at the very front of our lab. And I can't wait to show some of you guys in person someday soon. But at the front of the lab is our data center in an all glass enclosed environment. It's beautiful. So you walk in, you can see the data center and everything that's happening inside there. That's where the models are trained. From there, we have a 24-foot wide planar touch LED screen that acts more like a kind of like, I liken it to a what you might see in a tactical operations center or a joint operations center. We can actually we can pull up video feeds. We can do analytics on 16 different video feeds at one time. So we could have 16 video feeds coming off of UAS, unmanned systems, for example, all over the world. We can pull all those video feeds in, and we can do analytics on it using our supercomputing platform that is at the front of the lab and demonstrate that on the big screen that's right in the middle of our lab. Going from there, further down, we have a close quarter battle facility, and it's not not a live what we call a shoot house in the military. It's not a live fire shoot house or anything like that, but it's a it's a simulation environment. So it enables us to use technologies like IVAS, the Army's integrated visual augmentation system, and other kinds of mixed reality platforms to simulate combat scenarios in a very realistic environment. And we can actually put soldiers and operators, special operators, through those scenarios, and they can test the algorithms in an operationally relevant environment that were just trained on that supercomputing system at the front of the lab. From there, we have a robotics facility that allows us to build, bespoke platforms and do various types of unmanned system testing and collect a lot of different data. We use another facility close by that has 13 or 14 acres that allow us to fly outside of restricted airspace around DC, so we can collect a lot of data which is required to train our algorithms, our machine learning models. And so that flow of going from the where you train the models to actually testing them allows us to do everything we need to do to build a machine learning enabled capability, and then test it in an operationally relevant environment so that we know it's going to work when it gets out to the battlefield, or we have a very good, hypothesis that it'll work when we put it into the warfighter's hands downrange.
Yeah, it reminds me of Top Gun Maverick, where they do the simulation with their combat plan. That's pretty cool.
Rigby, that was a much more modern example. I was thinking all the way back to Men in Black, when in the shoot house, like when they're getting the aliens versus the little girl.
Yeah, that one too. Yep.
And we could do that. We could simulate aliens. If you want to come over to the shoot house and shoot aliens, we could do that.
You're on, Rob. We'll have a competition with that.
Okay.
So do you get these devices, like when you test on these, like the night vision goggles, or you mentioned IVAS, right? That's for the virtual thing. So do you get these devices? Do you make them, or do you just integrate with those?
Yeah, good question. So we are not a hardware company. So no, we don't make them. IVAS, for example, is made by Microsoft, and so loosely based on HoloLens. Not really anymore at this point, HoloLens, but yeah. So we don't make the hardware. We do the machine learning work on top of it, right? So on that platform in particular, we integrate an unmanned aerial system that can collect video, and we can train machine learning models to identify various targets of interest on the battlefield. And then when those algorithms detect the targets of interest, it could be perhaps a bad guy coming around an alleyway, right, that the soldier may not have seen. Those kind of threats, when we identify those with our machine learning algorithms, we can then stream that information in near real time into the soldier's heads-up display, kind of like you used to see in a fighter pilot. Fighter pilot would see. Now soldiers on the ground, the infantry soldiers, will have a similar capability.
Wow, that is life-saving indeed. So then you also mentioned you collect data, right? Especially when you fly in those restricted spaces and you stream that data. How do you can you give us a few examples on how you recognize patterns in that data? How do you leverage them for your algorithms?
Absolutely. So again, we're not exclusive to computer vision work, but I would say computer vision work is definitely our bread and butter. It's what we're really good at. And so for we use a lot of just like everybody else, we start with a lot of open source frameworks. One example, but not exclusive, is the YOLO framework. You only look once. We will. The process is just like any other machine learning process. Collect data. So we have operationally relevant objects of interest. Could be vehicles, people, other types of targets that will be in that environment. That 15-acre field, right? We have these objects moving around. We'll fly our drones. Sometimes we do day flights, night flights, different environments, cloud cover, early in the morning, late in the evening. You want as many different scenarios and types of environmental effects as possible when you train your machine learning model. And then we have a semi-automated labeling tool that we've created internally that prevents us from having to label every single frame in the video, because that would take just incredible amounts of time, as you know. So through this semi-automated labeling process, we label the data, then we bring it back to our GPU cluster here on site. We train a model to detect whatever object of interest the military tells us they want to identify. And as long as we have the data collected with examples of those objects, we can do that. We can train it to identify just about anything with a robust number of examples. And then we actually test the models. We take it back out to the field. We test them in realistic environments. And then on top of that, to make sure that they work, we've also built a MLOps, basically a drift detection capability. We call it Hatteras. That's what we call it, but it's essentially if all models drift, right? So all machine learning models drift over time for various reasons. But model drift is a real problem, and especially in the U.S. government, a lot of leadership hasn't caught on to it yet. They don't quite understand it, and so their business model has been, we buy a machine learning model, an algorithm, like it's a widget, right? Like it's an old school piece of software that doesn't have to be maintained. And the reality is, machine learning models all have to be maintained over time. They all drift over time. And so instead of selling machine learning models to the government, our philosophy is let's teach them to fish, right? Let's give them an MLOps platform that will monitor the model and monitor its performance once it's been put on the battlefield or wherever it's going into operations on an analyst workstation or wherever it is, um, and alert the end user when that model starts to drift, right? So if it's telling the end user that a T-72 Russian tank is a T-72 tank, but we detect drift, that may not be a tank, right? It might be friendly forces, and could cause, friendly fire, unfortunately, and we want to prevent that. And so we built this Hatteras MLOps platform to do just that.
So I think that's really interesting, and it's a piece that people don't always talk about all that often. But when models are drifting, I think you mentioned before that it depends a bit on like the model's architecture and other factors. But how often do they start to drift, or how long does it take before they do, and how long does retraining take?
Good question. It varies. The how long it takes for a model to drift varies. There is no there's no empirical, or there's no hard and fast rule for this type of model architecture always drifts every 3 days. There's just no way to put that kind of metric on it. So that's another reason we built this platform. So I hope it's okay if I tell a little anecdotal story, but I was demoing to a general officer in the Army several years ago, with one of my government counterparts at Fort Belvoir, Virginia. We were demonstrating a capability that took a nano drone, the video coming off of that nano drone, and we were able to identify people and vehicles moving around a space. And he said, "Awesome, great, that's a great capability, but who's maintaining that model? I don't have PhD data scientists on the battlefield. The Army doesn't hire PhD data scientists to go downrange." Um, and that kind of motivated us to develop this Hatteras platform. So Hatteras is that data scientist now. It is an automated PhD data scientist continually monitoring the model for drift. Um, so it could be some models drift, and it's based on the environment that they're experiencing, right? Whatever kind of how much. Essentially, if it's a more chaotic environment and the model is experiencing more scenarios it wasn't trained on, it'll probably drift quicker. Is kind of a rule of thumb. And once that model drift is detected, the retraining piece is it varies as well. We use an active learning process, so we try to keep human in the loop to some extent. And active learning allows us to recommend to the soldier, right? That's probably not a data scientist, but it allows us to recommend to a non-technical user which data needs to be relabeled, right? And it reduces the amount of time that takes. So we conceivably could, if we have a good flow of data coming back out of the environment that we're running the model in, we could conceivably relabel and retrain a model in a matter of hours versus some programs in the government it takes months for them to get data, retrain it, push it back down to the operational environment, and actually deploy it back to the battlefield. By that point, the model's probably dated and not really all that useful to the soldier.
No, that's great. In fact, at least I and Aaron can relate to similar use cases that we encounter, right? And the training on top, as we call it, is kind of similar, right? Is not just when the model drifts, but even understanding that specific domain, take an existing model, train it further with active learning, with the human in the loop, right? And make it more domain centric. So in your case, you said, hey, is this model detecting tanks, for example? Now, would it also detect other types of objects? And how do you make it more specific to that? So that's what we call domain specific AI in our lingo. It also happens in NLP. It's not just computer vision, right? There's different types of news articles. There's different trends that happen, and so when we see that, there is a drift in the model as well, and so we have to continuously maintain those. So in that sense, I guess, I mean, you're doing a lot of things that's like cutting edge. How do you find talent and data scientists and engineers or do you train them? Like, what is the mix there?
It is almost impossible. No, nothing's impossible. But I will say, anybody listening, data science and machine learning, there is still a market for you. I promise you. It's a talent that's in demand, despite all the news about what's happening in Silicon Valley. We, especially in this domain, ours, and speaking specific to Department of Defense and intelligence community kind of work, it's really hard to find folks that have a domain understanding and technical acumen. So we do find oftentimes, and I'm kind of talking about the problem. I will talk about how we solve it, but we find a lot of folks with the appropriate degrees and technical skills, but inability to obtain a security clearance, or or just no experience with really unique environments and unique data that we experience in DoD. Department of Defense UAS platforms, for example, drones, the video coming off of them is not pristine. It's not like you'd see in an academic or lab environment. It's got all kinds of artifacts in it that make it really hard to work with. But so finding folks that know how to do that is hard. Most of our team has been built from personal networks, quite frankly. We a core, the majority, the core of the team has just been built over the last few years of I know 3 or 4 folks that I've worked with in the past that I trust. I know they're talented and they know this domain. Let's hire them. Then they know 3 or 4. They hire, they recommend to hire. So really, it's worked that way for our team. That being said, we have a pretty robust intern pipeline. And we have a partnership with the Sangani Center out of Virginia Tech. So our founder, Mehul Sangani, is a philanthropist, gives to many different institutions. Virginia Tech is one. He invested somewhere on the order of $10 million of his own money to build the Sangani AI Center, which will be on site. They're building it right now at the AWS headquarters, the second headquarters for Amazon here in Northern Virginia. And that is going to be we're already pulling PhD talent from that pipeline, but increasingly that's where we're going to go to create our pipeline of PhD level talent.
So I live in Reston, Virginia, right with your AI lab, as I mentioned earlier. But are you seeing that there's a potential shift from some of the talent being, I think, very focused in Silicon Valley to coming over to this area? I mean, you have the Department of Defense, which, I mean, obviously there's a huge market in that area. And then you have AWS coming here as well. So are you seeing that there's an increasing pool of these people on the East Coast?
Yeah, absolutely. There are, I actually think at one point there were as many tech companies on the, was it 276 or 250, whatever the toll road, the Dulles, yeah, there you go, the 267, yeah, the Dulles toll road, right? Like just tech companies like all over the place. And I mean, it doesn't appear to be slowing down, right? And so I think the U.S. government, especially DoD, has really bought into modernization. And somebody asked me earlier today about why do we focus so much in O Labs on DoD AI problems? And I mean, you can do a basic, total addressable market analysis and see that DoD is spending far more money, even though HHS and some of these other agencies have massive budgets. They just do not spend the money on AI and emerging technologies that DoD does. That, in addition, I know my team here, the AI team here at O Labs, I mean, they are bought into the mission. And the truth is, I probably can't pay them as much as, well, maybe not Meta today, but Meta of the past, right? Could have. That's just a reality. That being said, I can offer a mission that Meta can't, right? And a call to service and patriotism and just doing things that not just patriotism but helping people detect cancer cells and things like that at National Cancer Institute, and just all kinds of amazing mission sets that we get to work on here, that a lot of companies just don't have. That they can't offer that. So long-winded way of saying yes, I am seeing a shift, and there's a ton of talent here in the DC area for sure.
Yeah, it's all about finding your purpose. So you guys are a good destination in that sense.
Yeah.
Awesome.
Rob, I think with that question about finding your purpose, you have some really interesting stories about what the technology has helped do as well. So, like pilot crash detection and finding coordinates for rescue personnel. So, could you share a couple of those stories?
Yeah, absolutely. So I think the one you're referring to is one that I experienced in the, I want to say mid 2000s. So we'll just say a 2008-ish time frame. I was a fairly new researcher at the Army ERDIC Geospatial Research Lab. So that's the Engineer Research and Development Center Geospatial Research Lab. That's a mouthful, but it's an Army-funded research and development organization, or agency, and we were collaborating with the Joint Personnel Recovery Agency. A lot of acronyms, but the JPRA, they're responsible for things like developing technology to rescue pilots that crash behind enemy lines. Um, and so they were looking for a way to reduce search space. So the way it used to work, and in some cases still works, a pilot may crash behind enemy lines, and they hide, they evade, and then the PJs, pararescue personnel from the Air Force, go out and basically do lawnmower pattern back and forth looking for these guys. And there's some educated guess involved and a little bit of technology, but some just hope, right? Hope they went over here. So they were looking for a way to use innovative technologies to reduce the search space and find the pilots faster. And so that was my introduction to machine learning, quite honestly, and predictive analytics. That's where I first learned about the power of this technology. And we used thousands of use cases, historical use cases of pilots crashing, and World War I, World War II, all through the different battles we've been in and conflicts and things, and what the pilot actually did, after action reports. And we use that data to train a model to do predictive analytics, to predict where, based on past performance, past, how humans have acted in the past, those historical cases, plus intelligence that we have, like enemy location, terrain, weather, those kind of things. All of that combined, could we use machine learning to predict where a pilot is going to go on the ground when they crash? And the answer was yes. And we were able to reduce search space by an order of magnitude and find pilots quicker when they crash. And then we use that same technology for California fire, to find people, at risk of in the path of fires, older demographics with Alzheimer and things like that, dementia, that walk out of their house and they just take off in the woods, and they're walking through the woods, and we need to find them quickly. We use it for that, and autistic children that wander away, looking for them, those kind of things. So we found that there were a ton of different use cases for this technology that we built for the military.
That's really cool. We are just about at time here, but Rob, I think especially ending on some of those ending stories was great. If just as a final CTA, because we did talk about finding new talent, if somebody was looking for a job and they were interested in Octo, who should they reach out to, or where should they go?
Oh, wow. Go to the Octo website. I would say reach out to me directly, but I might get a flood of contacts. No, you can reach out to me. That's fine. I'm sure you can find me on LinkedIn and reach out to me on LinkedIn.
Great.
Cool. Well, Rob, it was great having you today. Really enjoyed the conversation. I'm looking forward to shooting some aliens with you.
Me too.
Absolutely. Looking forward to it.
Access the full episode of Decisions Now on our website, and don't forget to subscribe to Decisions Now podcast today.